Hi students, I'm back here again with section 7.3 transformations. This time I'm going to be taking up 3 questions on page 264 to 265, questions 1, 3, and 6. And in taking up those questions, I'm actually going to be going over all 3 main forms of transformations: translation, rotation, and reflection. So looking at question number 1, use the figures, identify the transformation for which A, figure B, is the image of figure A. So when we're talking about these questions, it's important to understand when we say figure B is the image of figure A, so if B is the image, that means we start with A. We're always moving towards whichever figure is the image. So in B, figure C is the image, so we are moving towards figure C. So that means we're going from A to C. So between this one here, we have C and we have A, and because figure C is the image, we are trying to get figure A over to where figure C is located. For C here, figure E is the image, that's over here, and it's the image of B. So we're trying to figure out how to get from B over to E. So always remember that image, whatever figure is the image, that's where you're moving to. Okay, so let's start. Figure B is the image of figure A. So figure B is the image, and we're starting in figure A. And the question is, how do we get there? Well, this one is pretty simple. If we take this shape here, which is the same, and we move it up 1, 2, 3, and over to the right, 1, 2, 3, we can map it. So the way that you can do it in your notebooks, because you're not going to have a shape that you can move like I can here on the computer, is simply to start with points. So it's a good idea to start with maybe one point on both shapes. And the idea is, how do we get this point to that point there? Well, clearly we move up 1, 2, 3, and then over 1, 2, and 3. And the next step is how to write the answer. And this is extremely important for all transformations, whether you're translating, reflecting, or rotating. So we are going to say, figure B is the image of figure A. The transformation is going to be a translation. And by the way, sometimes that's referred to as a slide, because as you see, I could simply slide the shape over. You don't turn it, which would be a rotation, and you don't flip it, which would be a reflection. A slide is simply sliding in one direction or another. Now we're going to translate up 3 units and right 3 units. And that is it for A. Let's look at B now. For B, figure C is the image of figure A. So we're moving from A over to C. Now in this case, we can see that we can't slide. If I'm going to pull my original shape over here, we can't slide that. That's not going to work. It doesn't look like a mirror image, which is a flip. I can show you a flipped image of this. We can flip it in the y-axis there, and when we flip it, no, that doesn't work either. So this is a flip. You can see I've flipped it, but that doesn't work. So that's not going to work either. So instead, we're going to have to do rotation. So clearly I can write down that my first step is I'm going to need to rotate. So rotation is likely the trickiest transformation to describe, because there are 3 things you've got to include when you're describing a rotation. You've got to describe the direction which you're rotating. Are you rotating your shape to the right, which is counterclockwise, or to the left? And so we can say clockwise, CW, which is a rotation to the right. Or we can say CCW, which is counterclockwise, which is also known as a rotation to the left. Then we have the next part. How many degrees are we rotating? Are we rotating just a few degrees, or 90 degrees, or 180? Typically in these types of questions we look at 90-degree turns or 180-degree turns to make it simple. So you might have a 90-degree turn, or let's say a 180-degree turn. This is also known as a quarter turn, or in this case a half turn. And then the last one is perhaps the trickiest to understand. When you're rotating something, it has to be rotated around a point. That should say point. So I've set up this first shape here to rotate around this green dot. Okay, so if I'm going to take that shape and rotate it, that's a quarter turn clockwise. This is 180 degree clockwise. If I keep going, that would be 270 degrees clockwise. And then back is a 360. Just like if you're skateboarding and you do a full turn, that's a 360. 360 brings you all the way back to where you started. Now that was clockwise. We can also go counterclockwise. So this would be a quarter turn or 90 degrees counterclockwise. This would be 180 degrees or a half turn counterclockwise. Then we have 270 and back 360 degrees. Notice that when you do a 180 degree turn, you don't have to tell whether it was right or left, because if I do a 180 degree turn to the right, which is that, it's the same, or it lands me in the same position as doing a 180 degree turn to the left. So it's like standing like this. If I turn around 180 degrees and I move to my left, or if I turn 180 degrees and I turn to my right, I still end up in the same location. So when you have a 180 degree turn, you don't need to mention the direction. That's the one situation where you don't. Now in this case, we're not having any luck bringing this shape mirror onto C. And the reason is our point, where our point is located. We are now rotating around this green dot. But if I move that green dot, let's say up here, it's going to change things. Now I'm going to try rotating this shape around that green dot. There's a 180 degree turn. But that doesn't bring me back over here. Well, let's try moving down to maybe this corner here. Well, no, that's not going to work either. Looking at this, I'm going to look at this bottom right hand corner where the two shapes meet, and I'm going to try that. And we'll notice when we put the green dot there, this works as a turn center. So we have to rotate about, so in this case, it's going to be 180 degrees because we did a full half turn, about point, and then we have to tell people in writing where that point is. It's very easy for me to explain to you where the green dot is, and if you have a piece of paper, you can put a green dot and say about point, and in this case you would say about the point with a green dot. You could say that. The other way you could do it is if you have a grid like this, you could actually write down the coordinates for that point. So in this case, this is 3 and this is 4. So this point is located at 3, 4. So you could say rotate about the point at 3, 4. So I'm going to clean this up and we're going to write the answer nice and properly. So here we go. We are doing a rotation. So we're going to say we're going to rotate. We know we are doing 180 degrees. That's a flip, a turn of 180 degrees. Because it's 180 degrees, we do not need to give the direction because clockwise is the same as counterclockwise. And we are going about 0.34. And that's it. So for rotation, you need to determine which direction you're rotating, how many degrees you're rotating, and then about what point you're rotating. Let's move on to C. C says figure E is the image of figure B. So here is figure E, and it's the image of B. So we are going from B, and we're trying to get over to E. We can test if it's a slide. It doesn't look like a slide, okay? Because that's not going to be the same there. It kind of looks like a mirror image. It looks like if I flip that over, it's going to get there. If I take this shape here, and I flip it, yeah, that works as a flip. Now, just like when we had rotation, you had to rotate about a certain point, and very important just to go back here, we have to use that word about. That kind of means around that point, but we use the word about for some reason. For flips, instead of having a rotation point, you have a reflection line, or a line in which your object is reflected into, much like a real mirror. If I have a mirror located right here in front of me, let's say it's 1 foot away, my image is going to appear 1 foot into that image. If I step back 2 feet away from the mirror, my image will be now 2 feet into the mirror. It will look as if I'm 2 feet away. And that's the same way it works here. So we need to determine where is this line. You can either draw your reflection line, or you can indicate it as a line that goes through a certain point. I'll explain both of those. So just looking at over here at this situation, it looks like my mirror would be right between, and that's generally the case. The mirror is a line right kind of smack dab between your two shapes. So here is where I'm going to put this line. And so I could say figure E is the image of figure A, so we are going to reflect through the red line. You could say that, because we have a particular line already drawn there. But what if you couldn't draw it? And what if you just had to explain to somebody and you didn't have a graph? Well, here's the way to explain where that line is. We look at the coordinate grid and we say this is 1, 2, 3, 4, 5, 6, 7. So this point right here, this large black dot that I've made here, is 7. So 7 on the x-axis. And because it doesn't go up on the y-axis at all, it's 0, because this is 0 on the y-axis, right? We have 0, 1, 2, etc., etc. So this point here is 7, 0. So we have this vertical line that goes through the point 7, 0. Now, I can't draw a vertical line that goes through this point any other way. If I try to move this line over here vertically, it's going to go through a different point. If I draw a line over here vertically, it's going to go through a different point. So if I say that I have a vertical line that goes through the point 7, 0, there's only one way to draw that line. So the other way that I can answer this question is I can say the following. So I can say this differently. I can say reflect through a vertical line that goes through 7, 0. Reflect through a vertical line that goes through 7, 0. So I'm reflecting B onto E by reflecting B through a vertical line that goes through this point 7, 0. And again, there's no other way I can draw a line that's vertical that goes through 7, 0. So that way I've been able to show it without actually having drawn it. Let's go on to D. So in D we have figure A as the image of figure D. So here's A, we're starting with A, and it's the image of D. So basically it comes from D. We need to go from D over to A and explain how that happens. Here's D, if I have a shape on D, and how the question is how do we get to A? Well, it looks like it's a slide, we can translate over. And again, there's two ways we can do this. One way I like doing it that's really, really simple is simply putting a dot on one of the points of both shapes. So I put a dot at the top of this one and a dot on the top of that one. And then I simply have to say to myself, how do I get from this dot to that dot? So it looks like I go 1, 2 steps up. So this is going to be a translation. So I can say translate 2 units up. And then 1, 2, 3, 4, and 4 units left. And that's my translation from D over to A. Let's look at the next question. Figure C is the image of figure D. So C is the image. We need to go from D over to C. So how do we go from D to C? Well, the first thing we can kind of tell is it's not going to be a translation. Translation doesn't work. A flip's probably not going to work at all. So it looks like it's going to be a rotation. And so I've set this up much like last time. And I've got this point here, which is my rotation point. So if I set it here, you know, this shape, D, rotates about kind of the center. And that's not bringing me to C. So I'm going to move that point and see if I can find another place to put it. There we go. What if I put it right here between them? Let's see if that works. Ah, that seems to work. So this point right between them works. So I'm going to actually give that point a name. This is 0, this is 2, 4, 6, so this is 6. This point here, this green point, is 6, comma, and we go 1, 2, it goes 3 up. So this point here is 6, 3. So I'm going to rotate about that point. Which way am I going? Well, it looks like it's a 180-degree turn. So I'm going, if I go to the left, that's 180 degrees. If I go to the right, it's also 180 degrees. So it's a 180-degree turn, or a half turn, about 0.63. So this is going to be a rotation. So I'm going to say rotate 180 degrees, or you could say half turn, about 0.63. Or you could say about the green dot. Either of those would be fine. And that's how you indicate the rotation for 1E. Let's move on to number 3. Draw this flag on a coordinate grid, and here are the coordinates. We'll start with A at 11, 11. And I'm going to plot it here, 11, all the way up to 11. There's A, and B is 11, 13, and C is 11, 15, and D is 12, 14, which is right over here. And then we want to draw that into a shape. So I'm going to draw that into a shape, and it's going to be black. Let's see if this works out. And there's my shape. And then we're going to draw the image of the flag after each transformation. We've got 6 transformations we're going to go through here. So let's look at A. We're translating 3 units to the right. So I'm going to take my purple guy here. I'm going to translate 3 units to the right. Now, when you don't have the computer set up like I do, where I can simply slide my shape over, the easiest thing to do is mark some points on your shape, and I'm going to do that in black. So I want to go 3 units to the right. I'm going to mark this point in black and move 1, 2, 3 units to the right. And I know now that this part of the shape has to be over there. So I know my translation is going to be 1, 2, and 3 units to the right. They may ask you for the new coordinates, and this is kind of how you might list it. So here we have A, and this is B, coordinate B, this is coordinate C, this is coordinate D. When we have a second object that is an image, we use this notation, which is a little tick mark on the upper right hand corner, normally where you'd put the square sign for like centimeters squared. It's a little tick mark, and it stands for prime. So we say A prime, B prime, C prime, and D prime. And we could actually find those coordinates, right? So A prime is 14/11. And we can go and figure that those coordinates for the image for all of those 4 points. Now, so you should be comfortable finding the coordinates from the original shape that you're working from and the image shape. All right, let's go on to B. B says a translation of 5 units down. Well, I'm going to make a duplicate of this one if I can do that. Let's duplicate that. And I'm starting over here, and I'm going to go 5 units down. So 1, 2, 3, 4, 5. So there's going to be the image there. And if I did need to do the coordinates, I could go double prime, right? You could go A double prime, B double prime, C double prime, D double prime. Again, this question is not asking for that notation for each of those points, but it might, and that's how you would do it. Let's look at C. C is a reflection in a vertical line through 9, 0. So here's the tricky part that you've got to get comfortable with. There's 3 things going on here. It's telling us we've got a reflection. We can wait with that. It's telling us we're going through a vertical line. Fine, we know we're going to have a vertical line here somewhere. It could be here, it could be here, it could be here. Where does it go? Well, they tell us where it goes, where this line goes by telling us the point that it goes through. So where is that point? 9, 0. We just have to find that point. So 9 is on our x-axis, right? We have 9, 0. 9 is our x-coordinate, and 0 is our y-coordinate. So we go over 9, which is right over here. I'm going to make it maybe a different color so we can see it. So this purple dot right there, and 0 means 0 right here. We're not going up on the y-axis at all. So the line has to go through this dot, and it has to be a vertical line, which means it can only go right there. There's my vertical line through the point 9, 0. Okay, so we're going to be doing a reflection through this line. So we're starting here, and we're going to reflect the other way. Now I'm going to show you how to do this without needing the computer or anything else. So we take our 4 points. There's our 4 points here, and we look at our first one here. and we see that this point is 2 units away from the line. So we're going to go 2 units to the other side of the line. This D point here is 1, 2, 3 units away from the line, so we're going to go 1, 2, 3 units to the left. B is 2 units over, so we're going to go 1, 2 units over. And A is 1, 2 units over, so we're going to go 1, 2 units over. And that shows us where the points are, and we can simply now connect those points with a line. I'm going to make it a black line. And there we go. That's our reflection from this image over to the black, reflected in the line, the vertical line, through the point 90. Let's go on to D. So now we're doing, in D, a reflection in a horizontal line. So it's not vertical, it's a horizontal line through the point 08. So we know our line is going to go this way. We just don't know where it's going to go. Is our line going to go here, or here, or here, or here? Well, we look at the point 08. And again, very important part here. These are the hardest coordinate points to find, the points with zeros in them, because people get very confused. If I ask you for 6, 5, you can find 6, 5 over here. If I say 2, 10, you can find that, even with negatives. But once we add zeros, people get very, very confused. Don't. Simply remind yourself that it's the x and y coordinates. Right? The x coordinate is 0, which means it's right here. This is x. It's not 2. Our x coordinate is not 2. It's not 4. It's not 6. It's not 8. It's right here. It doesn't go to the right, and it doesn't go to the left at all. It stays right on 0. Our y coordinate is 8, so we're going to go up here to 8. So there is 0, 8 right there. So our line has to go through that point. So I'm going to draw a line right through that point. We will make this one purple. And there is our line through 0, 8. So we've drawn a horizontal line through 0, 8. This is the first step. You've got to get really clear on how to do that. Now we're going to reflect. So to reflect, I'm going to start back to my main image. I'll circle it because it's getting a little confusing with all the images. And now I'm going to reflect into this line. So now I'm going to go 1 point at a time. A right over here is 1, 2, 3 units away. So I'm going to count 1, 2, 3 units over here. I'm going to write down A. Try smaller. And B is 1, 2, 3, 4, 5 away. So I'm going to go 1, 2, 3, 4, 5 away. And here is B. And C is 3, 4, 5, 6, 7 away. So I'm going to go 3, 5, 7 away. So here is C. And D is over 1 and 6 units away. So 3, 4, 5, 6. And here is D. And now I'm simply going to go and connect them with a black line. And right there is going to be my reflection from this shape in the line, the horizontal line, through 0, 8. For question number D, we're moving on to rotation. So we're rotating a half turn about point A. So first things first, locate point A. Right over here, there's point A. And we're going to do a half a turn. And I've set it up so that I'm only going to be rotating around this point here. So that's not a good location. I need to move my point A, my rotating point around point A. And then I'm going to go a half a turn, which is going to lead me right there. I'm going to see if I'm going to get rid of that. So there we go. That's a half turn. This is 90 degrees, and there's a half turn. So that's answering question E. What about F? F would be a quarter turn clockwise. So a quarter turn is 1/4, which is right there. And clockwise, just as a reminder, the clock goes this way. It goes to the right. That's clockwise, CW. Counterclockwise goes in this direction, to the left. Think about the way in which the hand turns to the right. That's clockwise. And the opposite direction is counterclockwise. Sorry, that should say CCW. Now we're going to move on to number 6. Okay, so for number 6, it says, use grid paper. In each case, describe the figure you drew. Draw a figure for which a translation image is also a reflection image and a rotation image, and draw the translation image. So what I've drawn here is pretty much the simplest shape you can get, and that's a square. And this square, we can translate from here onto this shape over here. So I'm moving from here, my original image, into my translated image here. But what the question is asking here is, this is a translation, but it should also be a reflection. And yes, I can reflect. This shape can be flipped in this vertical line, this red line, right onto that same shape. Okay, so this translation is also a reflection, but it also is a rotation about the point around the green dot. So I've got it set to rotate around this green dot, and if I rotate it on that green dot, it's going to land in, well, pretty much the same place. I just haven't kind of set it up in the right spot, but that should bring me almost exactly to that same spot. So this square transforms onto here by translating over. Looks like it translates 1, 2, 3, 4 units to the right. It reflects in the vertical red line, and it rotates 180 degrees about the green dot. So for B, we're going to draw a figure this time where the translation image is also a reflection, but it's not a rotation. So I thought about the square, and I thought, well, I want to change the square so that it can't rotate. So that if I rotate it, it's going to change. So if I took this shape and I rotated it this way, it's changing direction. Where I had, this is like a house shape, where I have the roof starting by facing up. When I rotate it, the roof is facing down. That is going to be very different than if I start here and I translate to the right. The translation works like that. And also a reflection in that red line is going to flip me over right there. So in this example here, I have a translation which is going to be 4 units to the right, and I also have a reflection, but it's not a rotation, again, because if I rotate that, you can see the image turns upside down. So this is an example. This kind of house figure will allow you to translate and reflect, but not rotate. And let's look at the last one. So draw a figure for which the translation image is not a reflection, not a rotation. It's basically only a translation. So I'm going to start with this shape here. I've basically taken the idea of the house, which is kind of got vertical symmetry, and so I've taken that away by having it be one-sided. It's like a roof that's going up on one side. So it no longer has that vertical symmetry. So I'm assuming it's not going to reflect anymore. But I know I can translate it over here, so there's a translation. But if I try and rotate it, well, that's not going to work. And clearly, if I take this and I flip it over, let's take a look at what that's going to look like. Let's flip it over. I will flip it in the y-axis here. So if I have this reflection over here and I move it over, that's not going to work. It's not going to map onto my original translation. So in this case, we have a situation where it's only a translation. We will not be able to reflect, and we will not be able to rotate. And that's question 1, question 3, and question 6 for transformation.